Hi, in this video we are going to talk about how to use custom objects and how to construct a binary search tree out of a custom object. So let's consider the fact that we have, for example, a class person, and this person is going to implement the comparable interface. Why is it so important? It is so important because, as you may recall, this binary search tree can be constructed out of objects or T parameters that extends the comparable interface. So if this person wouldn't implement the comparable interface, we wouldn't be able to construct a binary search tree out of this person class. Okay, we have the unimplemented method. So first I would like to create some variables. For example, we have the name and we have the integer age. We have the constructor, and in the constructor I would like to get the name and the integer age, and we just have to set these variables accordingly. This.name is equal to the name. Okay, and then I'm going to override the toString method. In the toString method, I'm just going to return the information. Okay, so return this.name plus some spacing and this.age. Okay, I'm going to generate some getters and setters, so getters and setters for the age and the name. Ctrl-Shift-F to auto format, and we have to tell Java that, okay, we have this comparable interface, and Java has to know that, okay, is it going to compare the person objects according to the names or the ages parameters? And that's why we have this other person basically, and we have to tell Java that first of all I would like to return the name.compare to the other person's.getName. What does it mean? That we would like to construct our binary search tree according to the names basically. So the tree-like structure is going to store these persons according to the names, so whenever we make an in-order traversal, it's going to sort the person objects according to the name parameters, so in alphabetical order. Okay, so let's see a concrete example. So we have this person tree, binary search tree is equal to a new binary search tree. I would like to insert, for example, a new person with the name Adam and the age 27. I'm going to insert some other more. The Kevin with the age 13 or 13, okay, whatever. Then, for example, Joe with the age 67, then with the age 2 and 11, for example, Michael and Smith, whatever. And I would like to make an in-order traversal. So traversal, it's going to print out these person objects, and because we have specified that we would like to compare the objects according to the names, it's going to sort these person objects according to the names basically. As you can see, it is an alphabetical order as far as the person's name parameters are concerned. What if we would like to sort according to the age? We just have to specify here in the compare to method that I would like to have the age minus the person.getAge. Okay, it's going to sort these person objects, as you can see, 2, 11, 13, 27, 67. Okay, so basically these person objects are sorted numerically according to the age parameter. What if I would like to make this sorting in a reverse order? We just have to put a negative sign here. Okay. And basically if we rerun our application, as you can see, it is in descending order: 67, 27, 13, 11 and 2. So basically this is how to construct a binary search tree out of person objects. Why is it good? Let's consider, for example, LinkedIn or Facebook, where we have lots of users, millions and millions of users, and you have to search for a given user, for example. You start typing a name and basically you start searching for a given person you want to connect or want to send a friend request, whatever. And let's consider the fact that it doesn't matter whether we have to use a linear search in an array, which is going to take ordo and time complexity, or we just have to make a search in a binary search tree, which is going to take logarithmic and complexity. Okay, it does matter whether it has a linear running time or a logarithmic running time. The logarithmic running time is far better, so it outperforms linear running time. So this is why it is good to know how to construct a binary search tree out of custom objects, such as, for example, person or user or student or whatsoever. And I find it quite counterintuitive because Java doesn't support any built-in data structure such as a binary search tree or an AVL tree or a red-black tree. Okay, maybe you can import some libraries and it does contain these given data structures, but if you want to make a good underlying data structure, I think a binary search tree is a good guess. Okay, the problem is that it may become unbalanced, which means that this logarithmic time complexity may reduce to linear time complexity again. So that's why more complex data structures have came to be, such as the AVL tree and the red-black tree. Thanks for watching.